Next, we will discuss a characteristic root or value of the matrix. We know that the matrix can be used to express the linear algebraic equation set and the linear differential equation set. This is the example given above. A linear ordinary differential equation set with two variables can be expressed in the form of the matrix. The matrix A describes the basic character of x1 and x2. So how to get the basic character of x1 and x2's change? We need to solve its characteristic equation and characteristic root. The characteristic equation of a square matrix is such a determinant, in which lambda is a variable and I is the identity matrix. For this 2 by 2 matrix, the elements of its identity matrix is 1, 0, 0, and 1. In other words, only the elements on the diagonals are 1 and other elements are all 0. Lambda times I minus A is a matrix. It equals this. According to the definition of the determinant, it equals this. By letting it equals 0, we can get the value of lambda. Lambda 1 equals minus 2, and lambda 2 equals minus 3. They are called the characteristic roots of the matrix. Why call them the characteristic roots? Because the expressions of x1 and x2 all have such forms. In other words, the characteristic roots minus 2 and minus 3 describes the change speed of x1 and x2. It's the physical character of the characteristic roots. Well, here's a summary. This lecture includes two parts. The first one is calculus and the second one is linear algebra. In the calculus part, we've introduced the integral describes the accumulated effect and the differential describes the rate of change. Let's have a review. For t to the power of n, its integral is 1 over n plus 1 times t to the power of n plus 1, and then plus a constant c. Its differential is n times t to the power of n minus 1. For sin t, its integral is minus cosine t plus a constant c. Its differential is cosine t. For cosine t, its integral is sin t plus c. Its differential is minus sin t. For e to the power of t, its integral is e to the power of t plus c, and its differential is e to the power of t. In the linear algebra part, we've introduced three important concepts. The matrix is used for the standardization expression of the linear algebraic equation set or the linear differential equation set. The determinant is used for the standardization expression of the solution of the linear algebraic equation set. The characteristic equation and the characteristic root are used for the standardization expression of the solution of the linear differential equation set. We need to point out that we've introduced many mathematical definitions in this lecture, but as time is limited, they are not absolutely rigorous. We make efforts to explain them in forms of physical essence. For your better understanding, if in your following learning process, you may need to often review this lecture. Well, this is the end of this lecture.